So the first part of this talk is just covering web accessibility and giving you a primer on it. So if you've ever seen the abbreviation A11Y, that actually stands for accessibility, and that's because there are 11 letters between the A and the Y in the word. So sometimes you'll hear people call it alley, sometimes they'll call it A11Y. It doesn't really matter. I think it's kind of cute because it spells ally, and I think that's like really cute. So this paper mostly concentrates on the area of accessibility around screen reader use. So accessibility covers a whole range of both like permanent and temporary disabilities or just differences of access for people, but we're going to mostly focus on screen readers today. So some of the most popular screen readers here are listed here. I'm actually about to demo one of them. JAWS and NVDA, I always go to call it NVIDIA. They're like the really popular ones on Windows. So JAWS is like Job Assistant, I'm trying to remember now, I totally forget, but it's got this super enterprising name that makes you... Job access with speech, thank you. Suz, you're on the ball, thank you so much. And NVDA is something vision, I forget, but anyway, so JAWS is the really expensive one, and then NVDA is actually open source, and it's programmed by blind programmers too, which is super cool. So they're obviously dog-fooding their own product. So I think NVDA is like especially cool. VoiceOver is the thing that you might accidentally turn on your computer from time to time on your Mac, and it starts talking to you, and you're like, "What is this a virus?" And so I'm going to be demonstrating that. VoiceOver is also on iPhones as well, which is really, really cool. And so Speak Up is the Linux version that some people use if they use a computer with Linux and need a screen reader. And TalkBack is the Android equivalent for Android phones and tablets. So I just wanted to give you a quick primer on that. So I built you all a demo page so you can see how impactful it is to have proper image annotations in your code. So I'm going to go over that really quick, hopefully. Okay, so this is the demo page that I have. I might actually make it a little bit bigger. Is that cool for everybody? Reading the text is not super duper important, but so I'm going to turn VoiceOver on, and you're going to see like captions at the bottom, and you're also going to hear a really cool sounding Australian dude reading stuff out. Because I'm Australian, so I prefer my VoiceOver app to be Lee, who is from Australia. I hear Karen is very popular too. She's Australian.
VoiceOver on Chrome. Screen reader demo page. Window. Screen reader demo page. Web content has keyboard focus.
Now, normally it's sped up a lot more than this, and that's probably what you've experienced. I tried to slow it down because we're not all pro screen reader users, so just be patient while I go through it, but it's much easier to follow if they're not talking at 1,000,000 miles a minute. And so I actually have just the focus of this page now, but I can start going into the page content itself and hearing the screen reader read that out to me. Hopefully.
Link. Oh. Heading level 1. Screen reader demo page. Link. Go to AIM's paper implementation. Below this paragraph are some pretty nice photos.
And then this is where I'm going to show you the difference between an annotated image and a non-annotated image.
Close-up photo of a lion facing to the left image.
So that was pretty good. I know it's a close-up photo of a lion. Like, my opinion is that it's sort of facing to the left, so it just gives a little bit more context.
/CAG01 JPG image.
All right, so who picked up just from like, let's say you just close your eyes, which I should have got you all to do. Would you know that there's elephants in this photo? Probably not, so I'm gonna go back to the lion because the lion's a very chill description.
Close-up photo of a lion facing to the left image.
And then I'm gonna go back down to the elephants, which as you can see just reads out a ridiculous file name, which of most pictures on the internet are.
/CAG01 JPG image.
So you can see how much context you're missing. And so for this example, it's contrived, right? Like maybe it's not important, you know, that there are elephants, but if somebody's trying to get the context of an entire page, that can be super problematic, right? So this is kind of the annotation feature in HTML, which we'll go over, is the specific accessibility, I guess, like feature within HTML and the accessibility tree that this paper focuses on. So I just wanted to give you a brief intro to make sure that everyone knows what that is.
VoiceOver off.
And I will turn it off. All right. I can keep it on the whole time and let him do the presentation for me. That would be great. Okay. So, so for those who haven't done HTML before, this is an image tag. So you started off with the keyword image, which tells the browser, I would like to put a picture on the page, please. It has a number of attributes that you can supply. Usually the bare minimum is you give it a source or an SRC attribute saying, here is the path to the JPEG or the PNG or whatever that I want to show. The detail that helped that line get described is called an alt tag or an alternative text tag. That's what it's short for. And so this is where you, as a human, try your best to describe succinctly, but still with a good amount of detail that you think is relevant, like what the actual image is. So for me, like if I got you to close your eyes and said, imagine a gray cat asleep on a chair, you'd probably all imagine it slightly differently, but it's pretty clear what you would actually see in your mind. So that would be a good example of a nice succinct description. If the context of whether the chair was like an armchair or not was important, then you would obviously include that. That being said, you might think, well, what about images that aren't really like contextual? What if it's like, what if we're looking at a website from the 1990s and it has like an animated GIF divider with like flames and stuff, and it just has nothing to do with the actual document, someone just put it in there. We still recommend, in general, that you use an alt tag, but you set it to be an empty string. And then that means that the screen reader will actually skip over that. It won't necessarily say, you know, kind of like what we saw with the elephants, there was no alt tag at all. It wasn't even like empty, it just wasn't there. So that tells the screen reader this is really not important. So you're deliberately marking that as decorative in that way. And so again, decorative images are things like borders, and maybe you've got images for your bullet points and they just don't matter at all. That's when you would maybe be polite and just let the screen reader know not to read it out, because it must be really annoying to have to like sift through all of the context that doesn't matter to you when you're a screen reader user. So this is an excerpt from the paper itself, which is kind of what I just covered. And they basically educate you at the beginning of the paper. This is probably one of the most important sentences that I'm calling out, which is the W3C, which is the World Wide Web Consortium, recommends that the alternative text be a concise description which conveys the image's purpose. Because of the restriction within a popular screen reader program, not going to say which one it is, many experts recommend alt text of 125 characters or fewer. So this is going to be relevant to the algorithms that are used in this particular paper. There's no quiz, don't worry about remembering that exact number, but it's interesting to think of 125 as the actual limit. So what are the pros of taking like a description, what are the pros of like putting an alt tag on an image? Like, why would you even do it in the first place? Well, first of all, you could probably see in that code that it didn't take a lot of effort to put that in at all. It's not even 200 characters in total, including the attribute. It works with any image, so whether you're showing like an SVG or a PNG or a JPEG, anything that's compatible in the browser, as long as you're using an image tag, you can annotate it in exactly the same way. So it's actually really cool. And it's been supported in browsers since HTML version 2. Who remembers when HTML version 2 came out? A couple of you? This is the proposal here, the RFC 1995. So this is where they were proposing that an image tag has an alt attribute, and it's text to use in place of the referenced image resource. For example, due to processing constraints or user preference. So back when this came out, it was very likely too that your internet was really bad. And so if the image didn't download, you didn't know what it was. So even if you didn't use a screen reader, sometimes the alt tag would actually show up. Either that or the title attribute would show up kind of like with this blank empty box. And everyone remembers that with the little Internet Explorer red X and everything. Yeah, so it's been around for a really long time. And so it is like a very established standard way to do things. So there are a lot of pros to doing this because, yeah, it's easy, it works really well, and you would think that everybody knows about it. The cons of using alt tags and manually producing them is that it does require coding knowledge. So if you have designers who are responsible for sizing the images, preparing them, creating diagrams and things like that, they're not necessarily going to be able to be involved in the process of like writing descriptions and things. And in a lot of companies, they're actually siloed away from the development team, so they're not necessarily going to be able to have that conversation about how should we describe these things that are on the page, which ones are decorative, which ones are not. And so it is a shame that even though the code is relatively straightforward, it still does require you to have access to the stack, access to coding knowledge. It's also decoupled from the actual image. So if you have the same image on lots of different parts of your website, you have to make sure that that alt tag and the same consistent alt tag is attached in every single scenario. And a lot of people don't really, a lot of, I guess, images that need descriptions aren't really reusable components, which is kind of a practice that's having another modern kind of revisit. And components would actually help out a lot with this because you just keep reusing the same piece of code. But that's usually not what happens when it comes to like images. They tend to be repeated, but they're not repeated enough where you'd make a component just for one particular file name. And this has an asterisk on it because this is anecdata, but plenty of devs have little to no accessibility skills. I've worked on a large number of front-end teams over the last like 12 years, and usually the people that are really good at accessibility, in my experience, are the ones that have already left product teams because they're frustrated and they've started consultancies where they charge large sums of money to help those product teams. And so having developers that remember to do it, that know how to do it, that care about why it's important, that developers that tolerate things that can't always be automated, that kind of stuff is hard to achieve on product teams. I've definitely felt those frustrations. And so I understand that this is something that's not always going to happen, even if all the stars are, look like they're actually aligning. So I definitely try and have empathy for that because working on teams is difficult. So alt tags just sometimes drop by the wayside when you're in a sprint and you just don't have time to go through and think up thoughtful descriptions. So there is actually some real data and some evidence in this paper that talks about just how widespread this is as an issue. And so it says, however, on web pages, alternative text is often not found or it's actually not meaningful. According to blah, blah, blah study on the top 500 websites, only 39.6% of images were assigned alternative text. So that even means that there's a lot of decorative images out there that don't have that empty alt tag. So a lot of screen reader users are just like having to skip over all that stuff, which is really annoying. So one study of a data set of 18,259 images showed that only 5,930 images contain some kind of alternative text. So that kind of gives you an idea of like some super popular websites just as a base level don't have good accessibility built into their images. And just to clarify, like accessibility is such a huge, like broad practice. Putting alt tags on images is literally one of the lowest bars. So it says a lot about the state of the rest of the website as well. There would be a strong correlation between that and just how accessible the site is on a whole. And so there have been other attempts to solve this, which have been referenced in this paper as well. How do we get all of the images on the internet described, and then how do we actually have them described on websites? There's two different problems that you're going to tackle here. And so there was a group from Carnegie Mellon that created a game called Fetch, like P-H-E-T-C-H. I couldn't find it. I also looked at their other one that they made called ESP, and I couldn't find that either. All of the websites went to like domain squatting links. But this group tried to make a game called Fetch, which gamifies making good descriptive descriptions, and they break it out into teams. You get to be the describer, and then you have a bunch of people that have to figure out which image you described. So it's almost like, not Pictionary, but it's kind of like a really cool matching game. And so I thought that was really interesting. So that's another paper you might want to tangent on, but I thought it was really interesting. So some people are trying to gamify it, right? Trying to, like just use human nature to somehow get the entire internet described. And just keep in mind, this was a little bit of a long time ago. So this was from newscientist.com 2006. We hope to collect captions for every image on the web. In tests, 130 players generated 1,400 captions over the course of a week, which is actually really impressive. But at this rate, just 5,000 people could annotate all the pictures imaged by Google Images in just 10 months. So maybe that was true at the time, but I think we have a much larger beast to tackle these days, 12 years later. So yeah, but it's a really cool idea, and people have been trying to solve this problem for a really long time, even though the alt tag's been out for a really long time. And even I fell victim to trying to solve this problem recently, which is why I discovered this paper in the first place. This is a very harebrained talk I gave in November in Paris about how, hey, what if we used CPU cycles for good, like the SETI at Home project used to do, where it was a screensaver that used your CPU cycles to crunch data and look for extraterrestrial life, which I think is the coolest screensaver I've ever heard of. I was like, what if instead of Bitcoin mining and like Salon.com just came out with this week. What if we use people's spare CPU cycles to run sophisticated machine learning algorithms to identify and describe images, and then push that up to a centralized database to hold the image and the description, right? And I was like, we can do this, but we're falling victim to the same idea that you have to maintain this database, you have to have this decoupling of the image and the description. And so again, this is this paper's attempt to try and fix this, and so that's also why they referenced the previous fetch game. But I'm also referencing my own failed attempts too, because I think it's only fair to do that. So I found this paper because I was trying to fix this. Cool. So now that you know what the actual problem is, let's talk about the solution that they came up with, which was to use steganography. So there's no fear in raising your hand. Who doesn't know what steganography is? A few people, yes! Okay, I'm so excited. I'm so excited. Okay, because some of you will know what it is. And so you'll see that the algorithms in this paper, if you know what steganography is, aren't necessarily groundbreaking. It's not about the algorithms, it's about the actual idea. So steganography, wait for it, is the practice of concealing messages or information within other non-secret text or data. So you're taking information and you're like hiding it in other stuff. But then the stuff that you're hiding it in just looks normal. So I mean, that's probably the layman's description. So when I first found out about steganography like a while ago, like this was me, I was just like, this is so cool. And I was like, I'm gonna hide data in everything. Everything's gonna be a ghost. Anyway, when I was a kid, I loved these books as well, like all the books about ciphers and Rot 13, and I just lived for this stuff. And I was that kid that didn't really have any friends, so I would pretend I was sending messages, secret messages to people, and then I would just like decrypt it and try and do it the hard way. I couldn't find any friends that were into this stuff, so I'm really glad I've met all of you. So I thought, this is such a cool idea to use, like, yeah, what most people use. Like, people are using Skype videos now to bury text data within the actual video signal, which is so cool. And then they have all of these different ways to not make it look like they're streaming for long periods of time. And I just think the whole thing is awesome. So for me, I just thought that using it for accessibility is, again, like a pretty novel approach. So this is what they're prescribing. They have this thing called the AIMS model, which is just short for accessible images. In this paper, we are proposing a method that aims to enhance the accessibility of web pages with regard to image content. The proposed method provides a tightly coupled mechanism in which textual description is embedded in the images using image steganography. So steganography is obviously like a really broad thing, right? You can hide stuff in sounds, you can hide stuff in images, you can hide stuff in Skype streams, you can hide stuff in Excel documents and all sorts of really cool stuff. We're just going to talk about one of them today, and this is probably the one that you'll find online pretty commonly. It's about concealing text and images, and it's using the least significant byte method. So least significant bit. Least significant bit is a very long thing to type. And I have a lot of diagrams and animations. So if you see LSB today, we're talking about the least significant bit. And if you're not sure what that is, I'm going to talk about that too. So This is the draw the rest of the owl steps. It's convert the text that you want to put into, so like the description, like a lion facing left. Take that text, convert it into bits, and then store those bits in the least significant bits of the pixel data. And again, we'll talk about that in a second, why that is. Some of you will already know. So you're basically like, it's very tedious how you're doing it. You know, it's a bit for a bit in each pixel and things like that, but it's really cool. So let's say we take our description from before, it's the lion, and let's say we take just the first letter. Let's just try and hide a C in this image, right? So we take the C, and we look it up in the ASCII table, and in the ASCII table, it's character 99, so that gives us a number, right? And ASCII table lookup is pretty common, or the extended ASCII table is pretty common in a lot of programming languages. So in JavaScript, which is what I wrote my stuff in, it's just like car code at for the actual number. So you can essentially just assign like a, and it actually differs between cases as well. You can have uppercase as a totally different C to like a lowercase c number. So you take that. That's your ASCII character code. And then if you've got a number, you can very easily convert that into binary, right? Because that's what numbers can do. So we move it to base 2, which is binary, and this is what we get. So the C is actually just 11000011. So these are our bits. So for every character, we're going to hide 8 bits in this image. So like that's a lot, right? The length of it is going to be like the length of the string that we have times 8, but that's how we're going to do it. So very inefficient, but it works really, really well. So how do we hide these bits in there without anyone knowing that there's stuff going on? Well, let's take our lion, and let's just take 1 pixel out. And we can take like the top, far top left one if that's easy for you to picture. And let's say, you know, a pixel has like an RG, a G, and a B value, right? And that's how they all mix together to create the color that you see. So maybe the red is a value of 20, the green is 255, so it's like got a lot of green in it, and then the blue is 102. I don't know what color that is, I just made it up, but if anyone can tell me, that would be great. So what if we hid 1 bit in each pixel, which is what this paper proposes, because there's a lot of different ways you can do it, and I'll talk about the way that I did it. But when you think about it, every pixel, if it's got 3 values, you can hide like 3 bits in each pixel, right? So that's kind of your payload. So that's how to compute how much you can store in one image, 3 bits. So let's try and store the first bit of the C of our string. So when we take 20, again, we're going to convert that number just to straight binary again. And that allows us to observe what the least significant bit is. Now, when we talk about regular numbers, let's talk about like a million. There's not a lot of difference between a million and 1,000,001, right? And it's the same in binary. If I was to change this 0 to a 1, it doesn't affect the number value as highly as something like changing that first 0 here, which is known as the most significant bit. So that's why it's called the least significant bit, because it has the least amount of influence if you were to change it on how that actually like bumps the number up or down. So when you think about it, what if we just change this 1 bit in this pixel value, of which there are 3 that are combining together? You know, can we change that and not have humans notice it? It turns out that yes, you can do that very easily. Our eyes are really bad, and you can't actually tell the difference. And so here is kind of what we can do. We can take this least significant bit. Again, from the last slide, we took the C, we you know, like converted it into ASCII, then we convert it into binary. So let's pretend that we had a really long string of binary, which is like every character. We start just from the very beginning. So we start at the most significant bit of this character, but it really doesn't matter. It's really just a string of bits at this stage. So we take the 1, and we're like, all right, let's then just save that into this least significant bit. But we have to remember where we put all these, right, too. So that's coming up. And then we just flip it to a 1, because if this one's a 1, then we're just going to bump it to a 1. There's really only 2 options. So you're really not doing anything super dramatic to the pixel value for the red value at least. So that, in a nutshell, is how you store the first bit in the first pixel. And then essentially you have to keep going and going and going. And so this paper recommends that you then go to like I think the green pixel Either that or it was randomizing, but I'm going to show you the algorithm, which is why it's really confusing. But theoretically, you could take this green one, you could convert it to binary, and then you could store this 1 in the least significant bit of the green value as well, right? So that's kind of the approach that they were using, which is called the least significant bit, like image steganography tactic. So this is the diagram that they used in the paper. So I want to map what we just talked about to that, because this might be a little easier for some people to understand. So on the left, you've got the carrier image that you're going to put the message in, and you have, like, imagine this is just a never-ending, well, not never-ending, but a really long array of like RGB, RGB, which is kind of how a lot of, I know that PNGs are arranged. They have all of those values laid out. So if you can get the image in that format, you just have RGB, 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 RGB all the way down. Then you have your alt text, which is just like a stream, of bits, and you just go through all those pixels in order. So you look at the least significant bit of this red value for the first pixel, and you're like, all right, well, the alt text is 1, this one's a 1, so I'm just not going to do anything. I'll just leave it alone because it's already at the right value, right? Then you might look at the green one and be like, all right, the green one's a 0, but we need it to be a 1, so we'll just change it to a 1. Cool? All right. If you've got questions, definitely ask me later on. And that's kind of in a nutshell what they're actually doing. So here's the algorithm that they put out. So the first line, it's just doing a procedure. So it's just like naming a function, a method, whatever you want to call that. It's called least significant bit right. You pass in the carrier image. I'm guessing it's just the image data. So it's not like the binary itself, it's the pixel data of the image, because images can have like EXIF data and things like that in them. Then you pass in the alt text, which is the line, close-up of a line looking to the left. Then it looks like they're assigning these two variables to shorter variables just to just for brevity, which is fine. Then we're creating a loop. So I starts at 1. And then it goes through to the length of m, which is fine. And it just does it as many times as there are characters in the description. This is where it comes undone. So they compute ij. What does compute mean? Well, we can discuss that. So you find the ij of the carrier images like ij. So think of that as I'm guessing that I is the location of the pixel, and j is like, is it the R value, the G value, the B value, right? And it doesn't say how to find that pixel, how to decide on it. They do touch on this a bit later on. I'm sorry, I'm being very snarky. I just love this paper, it's great. And then you take that pixel to store the ith bit of m. So this is actually not looping over every single character of the alt text. It's looping over every single bit of the converted alt text. So that's a very important distinction to make. Then they have this new variable called p, and p is storing what the current least significant bit value is. I mean, it can be necessary to save time, but bit shifting is really fast, so I'm not sure why they were trying to optimize for this. And then if p is not, so if the current least significant bit value of that pixel color is not equal to like the bit that we're trying to set from the bit stream of the alt text, then store the message. Just like change it to whatever it needs to be. If it's a 0 and it needs to be a 1, then do that. Then once this is the whole thing. I feel like this is actually like Steganography 101. It doesn't really say anything about the paper, but it's fine. So then you return the annotated image when you're done. So you just loop over it all and you're there, right? And then to extract it, it's even more brief. You've got least significant bit read. You pass in the carrier image, and then it knows what m is somehow. M's a magic number. It's M for magic. There you go. It computes the ij again. It's like, oh yeah, based on the length. Well, I know where this first one's going to be. So you loop over it for the length of however many bits you want the alt text to be. maybe they just have an upper limit of 125. You compute the ij so that you can then just extract that out. And then you end up with this kind of stream of messages. And then you return alt text, which is not even a variable. So you would probably return m as just like a string and then convert it into ASCII again. So it's sort of not 100% complete, but I took a lot of liberty in trying to fill in the gaps. So here are the main assumptions that I'm having to make, which are, how do you know the length of the alt text? And what is the method to compute the bit position in the image? Okay, so for the alt text, there are a number of things we could do here. We could store the length of the alt text itself in a consistent pixel location in the image. So what if we designated the top left the first red value, the first 8, I guess, the first 8 pixels, or the first 8 pixel color values, which would be like 2 and 3/4 pixels, that would hold like a byte value, like a number of like how long is the text. Then from there, once you've abstracted it, you can then have m, and then you can actually go over the length of it. Or you could use a special character to indicate the end. So maybe you just keep extracting out like characters until you hit this ASCII one. You're like, oh, if it's ASCII code for end of file, then they're done. That can not really work very well either, for obvious reasons. And then you can also do natural language processing to just take everything out and try and find a string that makes sense in there. But that's very language dependent, and let's not do that. So that's like some ideas I came up with. And then computing the bit position in the image. They alluded in the paper that they're basically randomizing the locations, and they're doing that for the integrity of the image. So even if you can perceive the difference, even if you've got superhuman vision, you won't see this kind of weird line on the top that's been messed around with, that it'll just kind of be like evenly pseudo-randomly distributed, right? So I'm guessing that what they did was that they used a pring. Does anyone call it pring? I call it pring. Okay, sorry. It stands for pseudo-random number generator. I'm guessing that they seeded a pseudo-random number generator so that if you know the length of the alt text, you can just generate the same sequence of numbers, but you have to know the seed. So there's that detail too. So there are all these kind of caveats to doing this. But they did say that they did it with a random generator, or they were doing randomized pixel positions. So that's what I did in my implementation. Let's just move on. So browser extension. A browser extension is a third-party script that users can install, and that script can run on pages loaded by a user. It's also a terrifying way to give third-party code a same origin policy waiver. And I know that a number of browser vendors have had to remove malicious extensions for doing really naughty things to your page. And theoretically, like an extension could steal credentials and things like that. So they're not a super secure way to do things, but the authors of the paper decided to do a browser extension, which I actually think is a really cool proof of concept. I think it's a really cool idea to do that, because browser extensions, or I write browser extensions and bookmarklets to kind of patch up the internet. So if I want a shorthand for a search query on GitHub, instead of having a bookmark, I'll make a browser extension so that it just adds another tab to like my pull request view, so that I can see the ones for a specific search set. So I kind of do it to hack websites as well, just in nice ways. So this image. Sorry, that's a genuine cough. This image, you don't have to worry about any of it. You just need to worry about the box on the left. But we do kind of start on the right. So the first kind of rectangle region is the web developer and what they would actually do in order to get this description to the user. So they would take a carrier image. I don't think web developers wear suits anymore. Anyway, they take the carrier image, they take the text description, and then they do the algorithms that we just talked about, and they put the annotation in the image, right? So that's their tool called Ames Builder. They did build it in Python. and Flask or something like that, which is interesting. So that's how they did it, and they had a web page where you could drag and drop it. So if you look in the paper, there's like a screenshot of it. It actually looks super user-friendly, it looks very accessible. So it's called aims.builder. And then you have this web server in the middle right, which is just hosting your web page. So once you've annotated all these images, you just use them on your website. They have the secret stuff in there. And then on the other side, which is the left box, is the actual user, and they do look like a spy, but I think it's supposed to be like someone who uses a screen reader. So they go to abc.com. They have the AIMS extension installed, right? And the AIMS extension is pretty cool. Like you press a certain shortcut. I think it's Control-Alt-U or something like that. And it does like a chime to say that it's been activated. And I thought that was a really cool feature. It will then, basically any page you visit while you've got it activated, it will read the text from the image. It will update. It will like get that text extraction out if it's there. It will then add in that alt attribute to each image. So it will manipulate each image tag and add that in, which I think is really cool. So that's what that browsing assistant / extension does. It uses the second algorithm we talked about, which is the decoding one. And here is another algorithm. So this is the aims.extension algorithm. This is how it actually does it. So it basically, like Chrome extensions or like Edge extensions and Firefox extensions are all just like a script. So every time a page loads, the script is allowed to run, right? So this runs the web page, kind of like the web page, I guess, environment or the context, the scope, the window is accessible to the function. So it's going to create a variable called HTML where it just gets the straight up HTML of the page. I'm guessing it gets it in a DOM-friendly way where you can traverse it and it's not just HTML string, because that would be the least fun ever. It then creates an image list variable where it's getting the images. So I think get images was documented, I'm trying to remember, but it will just basically go through the HTML and just like use like DOM query selectors. That's what I'm guessing it does. So once it's got that, it seems to have an array of images in a list. It will just kind of go through the list until it exhausts it. It will assign a new variable called image, which is just the index of the current image that it's on. It will create a new variable called alt, and then they have a function called getAltText, which is just like I guess like another name for the decoding function that we looked at before. It will extract that out. Oh, sorry, no, I'm wrong. So it gets the alt text. So the reason why I got thrown off is because that HTML argument is wrong. So I think that argument is supposed to be image. Yeah, cool. You're all on the ball. I'm not. But I'm talking, so I'm distracted. So it's supposed to go through each image and say, is there an alt tag on there? Is it empty? Like if it's just missing in general, then that's when it wants to take action on that image. If it's not there at all. So if the alt is empty or if it's null, then we want to read the text description out of the image. Yep, so there's the LSB read. So they did actually call it the same thing. Sorry about that. So it'll grab that out from the image, and I'm guessing that's just the image data, because it can't just kind of get that from the DOM element it was making. So it's just very confusing. And then set the image alt text. So that's where it would just basically again use DOM manipulation to add an attribute with JavaScript. And then it returns the web page, which is not really what it does, but I understand that like that actually makes sense academically, or if you're a functional programmer, or again, it's fine. I'm sorry, I'm not knocking on them. It's more that this one in particular, I was just not sure how to implement it, but I ended up just doing it my own way. So the implementation, let's see how much time we've got. Yeah, we're fine. Okay. So I did an implementation with cats because I really like cats. This is on GitHub, by the way, so you can absolutely play with it. So I used just vanilla JavaScript. There's no frameworks. You'll see it's extremely vanilla JavaScript. There's a lot of wacky stuff I have to do because there are no conveniences. I'm using HTML5 Canvas in order to get the pixel data out. So I'm happy to dig into the code because this talk hasn't gone as long as I thought it would. And I have a bunch of preset images on this page that you can test this out with, but then you can also upload your own. So I didn't really put any kind of thing that dumps the iTunes. Okay. I have a cron job running on my computer that checks what I'm playing on iTunes, and then it dumps out a text file, and then I import that into my Twitch stream so that, because people are always like, what song is that? And now they know. So sometimes I forget to turn off the cron task, and iTunes gets angry at me. So anyway, so this is my implementation. What I ended up doing was I am storing the length of the description as the first 8 possible locations that I can store it in, as a 8-bit value. I'm storing that just in the top left of the image. So I'm not doing anything too over the top because it was not really important to me, and the paper doesn't even describe whether that's a valid approach or not, so that's what I'm doing. So the first thing it does is it will grab that value out and go, oh, okay, this is a length of 56, so hopefully you can see that. Then it'll just generate, and I'm cheating because I'm creating my own seed for the pseudo-random number generator, and then obviously I know the seed, so I can just get it back out again. So I then use the global seed to just create that sequence of locations for me to hide that data in, which location pixel I'm using. I am only appending data to the least significant bit of the red values, and that arguably creates the least amount of perceivable change in the pixel. Apparently red is just the hardest one for us. I'm not really here to, there's probably papers about why that is, but it's not because red cars go faster. But I did actually try and look it up last night. We were looking at the way cones perceive things and how stuff bounces off with the red value, or it bounces the least off or something, I forget. But anyway, I just did it with the red values, and it just actually makes my code a lot easier. As well, and it's kind of more like true steganography, so I did break the rules a little there. So that's kind of how I did it. I am going to now just show you a couple of images. So when you choose one, you can see that brief delay. So the one on the left is the original one, the original image, so as soon as you load it, it just chucks it in an image tag on the page. Then there's an invisible canvas that does all of the embedding, and then this is the embedded version. So as you can see, you might think that you see a line up here, but it's not because it's in both of them. So that's just what the image looks like. And then we can get kind of another one with a different tone. So you can see here, this is a cup of coffee on a table in front of a handwriting and a notebook. So this is not just cheating and grabbing what I was putting in there. It can actually bring it back out again. And if you look at the code, that's literally actually what it's doing. And so if we turn on a screen reader, and I'm just going to close this just so it doesn't get confused.
VoiceOver on Chrome.
Okay.
A11Y Steganography window. A11Y coffee or no file. Choose file. Choose choose file button.
It's really hard to make file upload elements accessible after you've messed around with them with CSS. So if you want to know how to do that, you can literally steal my code, because that is something that people screw up a lot.
Choose no file. Alt embed text /8BF0118878A6-4ADB1CDE82DF7927D6.
Sorry, I silenced it because it just keeps going. So I downloaded this image from pixabay.com. That's why it's got a weird GUID as a name. And then, so that's what someone would hear if I was just like, yeah, pixabay.com, commercial-free images, let's whack it on the page because it looks fancy. And then we can actually go across this image.
A cup of coffee on a table in front of a handwriting in a notebook. Image dead. Menu 13 items. Closing menu. Web voice elements tab panel.
Just going to turn that off. So as you can see when this goes away, there's image ID embedded, and that's the alt tag there. So it does actually take the image and take it out. So I can also do this with other files. I took a lot of screenshots today for this. Let's do a picture of just, come on. Oh, wow. Okay. So that's a picture of a cartoon picture of me. So I can say cartoon picture of the presenter with, this is important, NASA t-shirt. So I'm going to go to embed text, and I'm kind of stretching the image. But you can see there that I can't prove to you that it put it in, but it is embedding it, and then that there is sort of the proof. That was my timer. It is the blob that comes straight from the canvas after it kind of manipulates all the pixel canvas data, so that's sort of how it works. So yeah, so that's just a really quick intro of how like I implemented it. But you can actually go to all of the source. I have it all there. I am web packing it, but I did leave all of the source kind of like unminified and everything. So how my seed is 42. So you can see where I'm generating my indices. I'm embedding stuff in the byte. I'm embedding a header. I'm embedding a description. I can extract bytes. I can extract the header because I know exactly where that location is. Get the description length is just extracting the header. So I have all of that code, and I tried to make it as nice and readable but also modern as possible. So if you have any questions about that, just tweet at me. But it was really, really fun to implement. Again, I took a lot of liberty with it because I had a lot of freedom to kind of choose the best approach that worked for me. So yeah, let's go back to the presentation. But that was actually a really fun thing to do. And I had the perfect excuse to do it in the browser because technically I could make this a browser extension that just manipulates stuff on any page, right? But it seemed a bit redundant to kind of do that part of the paper. Okay. Cool. So pros of this approach, of this entire proposal in the paper. The description is portable with the image. I think that's really the most important thing. It's a huge strength, but it's obviously like a very fatal weakness as well, which I'll go over in the cons, because we haven't even talked about steganography attack vectors and things like that. But the description is portable with the image, which is just a really nice idea of being able to just throw the image on your site, and you don't even have to worry about coming up with the right description. It's less code, you know, because if you use one of these and you just have a quick script on your page that goes and puts all that code in, it's actually really nice to not have all of those alt tags, because a lot of the time you're having to deal with things like localization, which is another limitation of this, so it does mean less code in your stack. It's less effort because you're just not typing out the alt tags. And once someone has described an image once, theoretically, if you knew that the image was embedded in there, it just saves everyone so much work. Which is what kind of Fetch was trying to achieve. It's what I was trying to achieve. Like, describe it once and then just like hold that information somewhere for everyone to use. It's also just a rad use of steganography. Like, I'm still just like, that's so cool. So I thought that was really entertaining. There are a lot of cons. I'm sort of just summarizing some of them here. The first one is single language restriction. So let's say you wanted to caption an image in English, but you also wanted to caption it in Spanish, and you also wanted to caption it in French or something like that. It's kind of hard to do that. And then how do you kind of store all these different, it's like French starts here, and French has this seed, and English has this seed, and it's just a pain. So you would probably have to just store one language and then use your standard internationalization/localization strategies that you normally use on websites, of which is another accessibility thing you should absolutely be doing, but is one of the hardest things ever to do. Lossless image format is required. So when I import these images in, it doesn't matter if it's a JPEG, it doesn't matter if it's a GIF or a PNG, but when you actually then output that image, you have to have a lossless format, because you want those bits, which are actually some of the most vulnerable bits, like staying the same, right? And so if you put compression on something or anything like that, if you save it from the PNG you got into a JPEG, you're going to destroy that information. So you have to keep those images exactly the same. So the second and the third point kind of go together. Compression can destroy and corrupt data. There are ways to use steganography on JPEGs, and that's to use it in the same way that they use their compression algorithm, which is kind of cool, but you have to be careful about it, and again, it requires a new algorithm that wasn't covered in this paper, so I didn't want to go on a tangent. But there are actually ways to do it with lossy files, but if someone, you see this stuff happen all the time. People save stuff down and they re-upload it, and then Twitter compresses it again, and there are art projects dedicated to like just re-JPEGing things over and over again. So you can see that that's still vulnerable even if you can put it in a lossy format. The most significant human labor part of this is still not removed. you still have to sit there and come up with helpful descriptions. That takes longer. Tagging things takes longer than copy-pasting the alt tag once you've got the description, right? So they did tackle something that can sometimes just be seen as like an industry laziness, where people are just like, I don't want to do alt tags. But most of the labor involved in that, and most of the reason why people don't do it, in my opinion, is because it takes time. And it's difficult, and you don't want to get it wrong, and you have to do multiple languages, and it costs money. And also, the Chrome extension was great, but it's very opt-in. You're going to have your standard adoption challenges. You're going to have to say, let's standardize a seed, or let's just do like linear pixel storage, or like maybe we have to make this part of Chrome, and it's also part of Edge, and it's also part of Firefox. So for me, it's like it's a great little bespoke demonstration, but getting widespread adoption and access to this is going to be a massive challenge. Getting buy-in is something that, yeah, it's going to be very difficult to do. So there was that caveat too to the browser extension part of it. But I think the browser extension was a neat way to demonstrate it. So that's pretty much all I had. I hope you enjoyed it, but I kind of want people to ask me questions, because I just didn't have time to cover everything. So, but yeah, thank you.
Thank you very much. I know we have some questions out there. We're going to go in the back.
Could you, Jesus.
I told you they're loud. Yeah.
Could you use the content description length as the seed?
That's a good idea.
Because then it's always, yeah.
So just the word content description?
Oh no, like because you have the length of the length of the description, just use that number as the seed.
But then how do you, when you get like an image, how do you know how long that is?
Well, I mean, because when your script reads the image, it looks for those bits to see how long the description is, right?
Yes.
Right. Why can't you use that as the seed for the random number generator?
Oh, yeah, that makes sense. Yeah, that'd be great. Sorry, I thought you were talking about something else. Yeah. I thought you were talking about how to tell people how long it is on the other side.
Oh, yeah, no.
Yeah, that's a really good way to do it. That totally eliminates the seed thing. Thank you.
Cool.
I actually had a question as well. What if you run it on an image that, how do you know that this information is in the image? And you try and, how does the script know that there's text in there and doesn't just randomly parsing and getting garbage back out?
That's what I don't know either.
Oh, okay.
Yes, so I forgot to mention that, but how do you know?
Because the steganography means it's not discoverable, right?
Yeah. So how do you know? It's so true. It's so true. So that's something I never solved either, but I was just like, you could, and that's where the natural language processing craziness came out, and I was like, this just isn't worth it. But yeah, it's an interesting challenge. Like, how do you know it's even in there?
I've got one that's a little simpler than that. You could just put a signature.
Yeah.
So you could just put like 128 characters that you're expecting some signature string, and then if you see that, then you know you got it. And you don't have to apply that to the 127 limit. It's just something you can just stuff in there.
Yeah, that's really smart. So I'm pretty sure everyone heard that, but it was just about putting like a signature in there so that you look for that signature, and it might be in a very specific place, and if it's there, then you know to find it. Yeah, that's a really good approach.
So first of all, IJ is actually, I think from the paper, it's a computation of the vector function of the pixel itself, and one of its RGB values. That's what IJ is. And then the reason why they don't use the bit shift is because it uses a mapping function to recalculate what the actual value was, what the actual value at that position was.
Oh, that makes sense. Yeah. So if it's like 254, that would be a 0-bit position. So they just bump it up to 255 if they need to store a
Then you have
bit.
to store a value. Yeah.
Cool. Yeah, that works.
Yeah.
Yep. I use bit shifting because I love bit shifting, but yeah, that works. That actually makes a lot more sense, and it's something that they didn't explain in the paper. So thank you so much. I'm really glad that I know that now, because I know that that's a different approach to like storing the bit. That's awesome.
Okay, and then my question is actually, what happens when you crop an image, right? Like that's the first part, and then two, when does the processing actually happen? Is it on render or pre-render? Because there are some CSS transformations that put maybe an image out of focus, like that shifted maybe left 20 pixels or something. So if it's on render, then wouldn't that affect what the view? Are they processing the view, the view of the photo, or the asset that's in the page?
Yeah, that's some really good questions. So with cropping, I think that the randomized positioning would obviously help a little with that. Like if you put everything in the corner, including the header that I put in there, cropping is probably like those edges are the most vulnerable, right? So yeah, that would absolutely destroy data if you had it there. So even if you had a random generator, if you cropped it, it would also like offset all of them. So then you would actually lose the positioning of everything too. So cropping is probably the most dramatic thing you can do. Even if you just crop like a pixel off each side, you're screwed. Yeah, totally. As far as like what the browser extension does, they don't document that, and they kind of, well, they do, but they sort of do it in a weird way. So they say that they download the images from the server instead of just slurping them up from the DOM. So in my opinion, maybe they're trying to get around the fact that maybe you're manipulating them. That being said, like an asset itself shouldn't be affected by a CSS like hardware filter or something like that. Like it wouldn't actually affect you being able to grab those pixel data out, but at the same time, I want to show you this because it is a bit weird. There was a picture where they had one of those like sequence diagrams, this one. So this is what happens when you use the extension, and this is where it's like it gets the web page HTML, then it gets the image URL, and then it goes to the server and gets it. So it's almost like it's trying to get that intact image. So that might be a reason why they're doing it. But to me, I was just like, but it's already cached. Like, can you not just use that? But yeah, I thought that bit there was very, very interesting to me, and I didn't really have time to cover it. So yeah, it's a good question. But I think that there probably answers it for you.
It sounds like they're just doubling your bandwidth.
Yeah, that's a downside for sure.
Other questions? Oh, yeah.
Hey, yeah, so I have kind of a dumb question. I don't know if it was covered in the paper or not because I didn't get a chance to look at it, but why not just use EXIF data to achieve sort of the same effect? I know it's an obvious question, but I'm just curious.
No.
Okay.
I'm so glad you asked, because when I mentioned EXIF before, I realized I totally forgot to talk about that. So EXIF data is like a very common practice that's already standard, where you can store stuff in plain text, seemingly, like, if you have the right app. In the actual image. The downside to that is on social media these days, Facebook, Instagram, a lot of other social media applications, they will strip all EXIF data out. And they kind of do that mostly for privacy, because a lot of users don't realize that there's GPS location data in there now. Like I have that turned off in my phone. If you don't, you might want to turn that off, but it's embedding the location in all of your photos. So if you upload your photo to a site that doesn't scrub that, anyone can dox you if you took a picture of your own home. Like, I mean, to a degree, they could figure that out. So that's a little bit scary. So like, I think that EXIF data was seen as vulnerable, and I think that might have been covered in the paper. Because I'm trying to think of why I didn't think to cover it, but I'm pretty sure it's in the paper where they said it's vulnerable to social media.
Okay.
Yeah, it's a really good question, because I mean that would be the obvious choice, and it's literally a description field, isn't there? Yeah.
Other question? Oh, we have one up here.
Did you try breaking the 125 character limit and just seeing what happens if you encode a very long body of text to see how much changes the image in that case?
Yeah, so I did do like a really long one, and I just couldn't perceive a difference either. I think part of it was that I was using just the red value, and so again, that's the least perceivable change. The one thing that I didn't do in my code, so feel free to like yell at me on Twitter, is I didn't bound check. So I didn't look at, oh, what's the length of the pixels, what's the length of the description, do I have enough pixels to store it? The algorithms in this paper actually say to do that. I just either forgot or got lazy or something. So it's not in there, but I wonder if it just kind of gets chopped off. But theoretically, you should do a bounce check on your, or give a range in your number generator. Yeah. I hope that answered the question. Okay.
Hey, I'm just wondering if the paper justifies, or maybe you have an opinion about if the description of the image should be centralized, as in should it always be a literal description of the image, or is it the meaning of the image contextual, right? Like if you have a meme, like the description could be like very literal. It might not capture quite what the author is intending. Do you have any opinion about that?
That's very true. So the recommendation generally is don't just describe something literally, like pick out what is important about it or pick out what is the joke part of it. It's funny because just recently on my Twitch feed, I made a meme reader and it just does OCR on images. And then it tries to find like what the main subject is of the image as well. So at least you get that text out of it, because meme text is incredibly inaccessible. And think about how often you've sent memes around and people just see like what is it called, like memeflip.com/GUID, and that's what they get to hear. So memes are a really good one. I would say if you put memes on your site, maybe just name the person or the character in the meme and then say what the text is. That tends to be how I do it. So on Twitter, I annotate all of my images, and memes are the most fun for me to type up.
Other questions? You're allowed to ask too.
So I'll torture myself to make it a question and not a comment. But you kind of answered one question I had, which was the pseudo random number generator. How does that limit the size of an image you can have? But you said you didn't bounds check, so you don't know. All right. So here's the stupid question. Here's a trick question. While cars are driving themselves, how many years do you think it would be before a screen reader could send an image out to Google or Amazon to get back an analysis of what's in the image if somebody wanted that?
How far do you think it's away from like it being?
Right. Well, right now I could send an image to Google and I can get back the OCR of the text in a meme image. And how long do you think it would be before you could send 5 images out to Google and have Google tell you what the alt should be, just based on machine learning?
So right now you can definitely get a good description. This is really sorry, that's fine. I was like, so right now you can, if you use Google, IBM, Microsoft Cognitive Services APIs, you can get a description back. Whether or not that's like contextual, that's going to take a while. So what I would suggest is that it would have to be a separate algorithm that looks at the content and the text of the page maybe and the things surrounding that image, gets the description back, or maybe submits both of them, and then makes a decision as to like how it's going to describe that image. That's really the only gap, given that right now we already have stuff that comes back saying it's a brown cow in a green field. Like we literally have that right now.
And I shouldn't do this, but that adds a con to your list, because what that's saying is that not only is a weakness of this that you have a single language, a weakness of this is that you might want a different alt based on the context of the image and how it's being used.
Yeah, exactly. So the only thing that I could suggest is that you have to make a round trip every time and submit the things that are neighboring it to see whether or not you can get like better context out of it, and that sucks. It's just not going to be there. I did make a thing called InstaCaption. Don't use it.
That's the best. That's always the best warning on any README. Do not use this.
Well,
oh, okay.
For a couple of reasons, for like data privacy reasons, right? So I'm using the Microsoft Vision API, and I'm like slurping up images from Instagram, because most Instagram people are just like, summer life, and you're just like, yeah, but it's you with an ice cream. So you know, Instagram will sometimes use your little caption you write as the alt tag, and sometimes it doesn't. So I sort of tried to do a thing where I just have these extremely professional descriptions of your Instagram picture, and some of them are really funny. It'll be like a guy in spectacles standing in front of a mirror, and I'm like, it's a mirror selfie, you know what I mean? So it's really cool. So it just does this thing. It watches for like new images as you're scrolling, and it just keeps it just keeps trying to replace the alt tags with very like machine learning like descriptions. So yeah, but don't use it. But I did sort of do that as an experiment in like Guerilla Accessibility. So yeah, I think we're far off having good context, not just some very verbose description that might not be relevant. It's a good comment to make.
Anyone else? Okay, I think that wraps it up. As always, the after. Oh, go ahead and applause. Let's go ahead.